Okay, this is Unit 9, Day 2 notes. And basically, the most important part about today is that we're just building on the stuff from yesterday. There's not very much new that we're going to talk about today. So I've started off with a couple of little reminders. Congruence means same size and same shape. And similar means same shape, but different size. It might still be the same size, but it can be a different size. And similar figures have corresponding angles are congruent. The angles are congruent. And the sides are proportional. That's the same thing we talked about last time. Angles are exactly the same, and the sides we set up proportions. Then we did a little reminder here. Remember back when we talked about congruent triangles, and we had these different ones, side, 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 side angle, side, and so on. We made the little foldable that opened up in the middle. Well, we have a similar thing with triangle similarity. And the one that we need to learn is angle, angle. And it says two triangles are similar when they have two sets of corresponding angles congruent. These other ones say that the sides have to be proportional. So here we're not talking about things that are the same, but just proportional. And this is the one that we're really going to use this year. So what we're looking for is find two congruent angles. So here on this one, the first thing you might look at this and say, oh, well, these angles don't match this one. But this is where you have to find the missing angle there. If I add these together and subtract from 180, I'll find that this one right here is 50. And if I do it on this one, I find that this is 45. So do I have two angles that match? Sure. Angle L is equal to angle X, and then I can pick one of these other ones. Angle J is equal to angle Y. On this one, remember that these little arrows mean that these lines are parallel, and in parallel lines, right, remember our parallel lines, I can say that this angle is congruent to this angle because these are corresponding angles. I can do the same thing on this side and say that this angle is equal to this angle. So in this triangle here, in the small triangle, I can say angle K, and in fact I need to call this one JKN, is equal to angle JN, this angle is equal to this one here, and I can call this one L. Then on this side I can do the same thing. JNK is equal to this one here, M. I could also say in this one, angle J in the small triangle is equal to angle J in the big triangle. Here, this kind of looks kind of weird, but we can still figure this out by doing our angles in a triangle add up to 180. If I start with this big triangle here, I know this angle is 50 and this one's 85. Add those together, subtract from 180, and I find that this one right here is 45. Then if I look at the small triangle, I'll see that in the small one, that one's 50 and this is 45. Add them together, subtract from 180, and I'll find that this one right here is 85. So do I have two sets of angles that are the same in the pink one and the orange one? I do. I can do like this 85 one, that's PTQ, angle PTQ is equal to this one here, angle R. And I can do the 45 ones, here this one, so this is PQT is equal to angle S. I could then also do the 50s if I wanted to. So that's the first thing we're going to do, where you have to figure out, are there two angles that are congruent to each other? Then we're going to add some little word problems. And honestly, these are not any harder than the ones we did last time. We just have some words that go along with them. One way that similar triangles are used is to find the height of things that are too tall to actually measure. Like if you wanted to measure the height of the flagpole out in front of the school, you probably don't have any way to climb up to the top and hold a yardstick or something to measure it. So in order to measure it, we can measure the shadow that it casts. Because as the sun is over here, here's the sun, it's going to cast a shadow on the ground here from this, and a shadow here. And because the sun's rays come in a straight line, these two triangles will be similar, and we can write proportions. That's basically what this says here. So all we need to do is once we have the picture set up for us, then we just solve it like any other proportion. 5.5 goes with x, and 4 goes with 29. Cross multiply just like we did last time, and we get 39.875 feet. As I said, if this is almost 40 foot tall, that would have been really hard for us to find a way to physically go out there with a tape measure and measure how tall it is. But because we can measure the shadows easily on the ground, we use this. They actually use this to find the height of various things. All right, I have a couple more examples here. They also do it when they're doing surveying to find, for instance, the length of, say, a pond. You can take a surveyor can go out there and take some different measurements, like this, to set up similar triangles, and then estimate, say, across a pond, like a body of water, which would be hard to measure across the top of water. So we just need to set up a proportion just like normal. 3 over 5 equals 12, and this part of the pond is what I'm looking for. I'm going to call that P. 12 over P. Cross multiply, and we find that the pond is 20 meters. And finally, the height of the Eiffel Tower, we could do the same way. This time, instead of using shadows, we're going to do it where this person, they look at a mirror, and if you know how far you are from the mirror, your line of eyesight will go to the mirror and then to the very top of the tower. And as long as you know this distance here, and then how far you are from the middle, this sets up similar triangles again. So I'm going to call this H for the height. 5 over H equals 7.5 over 1,500. Cross multiply, and what we find is that the Eiffel Tower is 1,000 feet tall.